Hi guys, I'm very much aware that I've left you in the lurch on the repair of this Jason Wobbulator, but what I've found is that almost every component is out of specification. The capacitors have drifted in value, the resistors have drifted in value, and it's sort of slowly breathing life into this thing, but there's a limit to how much time I can afford to spend on it. But I did want to go through the procedure of using a wobbulator, and I've actually bought a second-hand homemade wobbulator, and that's got some faults on it as well, but I think I've got those sorted out. So I haven't necessarily given up on this beast yet. Belongs to somebody else, so I'd like to fix it for him. But I got to say, it's not a top priority job at the minute. So I've got a wobbulator to set up. I haven't used it, so you'll probably be learning with me, and I'm sure I should get things wrong. But I just wanted to go through the procedure, let you see what I'm doing, and so as I can mentally draw a line under the the wobbulator saga. Anyway, it's a bit of fun, I hope. So we're going to have a look at the other wobbulator that I've got. Okay, this is the equipment that I've got set up on the bench. This is the radio chassis that I should be looking at, the IF transformers in that chassis. There's the speaker. Next I've got an old tele-equipment scope, and the reason I've got that there is I'm using the sweep output to drive the wobbulator. So as the beam scans across the scope, so it puts out a sawtooth voltage which relates to the position across the screen. I'll try and show you some more on that. Anyway, the output of that scope feeds into this device. This is the second-hand wobbulator that I've bought, so you have to give it a bit of attention, but I'll show you that again a little bit more. Next I've got my old Advance signal generator, and I've got that, I've had that cooking, and that's warmed up to 470 kilohertz. That's the frequency of the IF frequency for the radio. Then I've got my my ordinary scope there, and again an old frequency counter. And what I'm doing, I'm using the frequency counter to second guess the frequency from the Advance, and I'm going to use that to feed into the wobbulator to act as a marker, or at least I think that's what I'm going to be doing. This is a valve based frequency generator, so I've had it warming for probably an hour or so, and I've got that connected to the frequency counter here, and that's telling me that it's 470 kilohertz 0.02, so I think that's near enough for me. That's a 10-second count, so that's taking that frequency over 10 seconds. Yeah, 470220. That's plenty near enough. And that signal will be fed into the wobbulator to use it as a marker frequency. That's the case of the radio, and that's been shown on plenty of other videos of mine. So this is the wobbulator. It's battery powered, and you can find the circuit for this if you look for Radio Bygones Wobbulator. So time basing, and that comes from the X output of the oscilloscope. Then we've got control over the width of the sweep, the tuning, There's 4 ranges. Not all of them work on this particular unit, but we're using the lowest one, which is nominal 0.5 meg, and it's 2 meg, 5 meg and 10. There's a fine tuning and an output level, and then there's an output for a counter, frequency counter, and then there's a high and low impedance output there. I won't go through the whole thing because there's I don't think I'm going to have time, but that's the little board. So I didn't make this one, 2 9-volt batteries. So somebody else made this this unit. This is the output that I was talking about on the back of the scope, and I need that to drive the sweep frequency oscillator in the Wobbulator, and that's the earth connection there, obviously. And my other scope, this one, the Farnell scope, this scope doesn't have that facility, and I didn't want to go in there looking to get the time-based signal out of it, so I bought this old scope with the Wobbulator actually. The Wobbulator is driven by or as a voltage controlled oscillator, and what happens, the frequency is altered subject to this voltage. This that you're seeing on the screen here, this is measuring the output of this scope. So as that trace is driven across the X plane of the scope there, the voltage that is causing it to go across actually looks like this. If I slow it down, so I'll slow that down, let me slow that down as well. Okay, so you can see as this goes across, this is the voltage. It's a bit miserable because if I look at ground, that's the ground level there. So as a DC level, you see it's what's that? That's 5, 10, 15, 20, 25, 30 odd volts up there. So coming down to about 15, so 15 to 30 volts there, and it's that voltage that gets driven into, oh beg your pardon, that gets driven into the front end of the Wobbulator. So I hope that makes sense. And as we go faster, so, and it's that voltage that causes a change in frequency out of the Wobbulator, and it's that sweeping frequency that we want to feed into the IF transformers. So what I have now is the output from the scope being fed into the Wobbulator, fed into there, and then the output of the Wobbulator is being displayed here. And hopefully, if the camera is catching it, you'll see we start off with a high frequency, and then as the trace moves across and that ramp voltage changes, so the frequency goes down. I'll just make some adjustments and just see. I'm adjusting the width there, so this is a greater rate of change of frequency. And if I reduce the width, you'll see we're only getting a very small change in frequency. So that's what the width control does. And there, I almost stopped it. So that's just sweeping over a range of frequencies, or a much wider range of frequencies. Okay, so I think you can see there it's going over quite a wide frequency range. I don't know if the camera catches it, it's probably all sorts of aliasing. Don't know if this helps to make a bit more sense of it, but what I've done is I've connected the output of this scope onto the top trace of this scope, so you can see that voltage is descending as the dot goes across the screen. As usual, I've rabbited on for too long, and I did intend this to be a single video, but it looks like I've got to go into a second video to complete it. But I assure you that in the next part I complete. Thanks for watching. Oh, and by the way, always check on the comments box or the description box, because if I've got any updates, I'll put it in there, and I'll also put a link into the next video. Thanks for watching. Bye bye.